Welcome you all. Today we are going to learn about expression evaluation. What is this expression? See, consider the given three examples. This is a typical example for an expression. Now, what is an expression? Expression is a collection of operands, operators, and parentheses. What is it? Expression is a collection of operands, operators, and parentheses. So, what is meant by expression evaluation? Checking whether a particular expression is valid or not. Consider this particular example. Here in this example, we are adding 2 and 3. So 2 and 3 are operands and plus symbol is the operator. So operator and operands are okay. What about the parenthesis? There are altogether 3 parentheses, but this is not a valid expression. Can you say why? Yes, because the number of parentheses are not equal. There are 2 left parentheses given in the expression, but there is only 1 right parenthesis. We know that an expression can be said to be valid only if the number of left parentheses and the number of right parentheses are same. So in this first example, the number of parentheses are not same because there are 2 left parentheses, but there is only 1 right parenthesis. So we are having 1 right parenthesis missing in this expression. So clearly this first example is not a valid expression. It may be an expression, but it is not a valid expression. Let us move on to the second example. What about this? Here also I am adding 2 and 3. Operators and operands are okay. They are correct in their positions. But what about the parentheses? See, the number of parentheses, that means number of left and right parentheses are equal. The count is equal, but there is still a mistake. What is it? Let us have a look at this left parenthesis. It is clearly a left parenthesis, a normal parenthesis. But what about the closing right parenthesis? It is a square parenthesis. We know that if we are using a left parenthesis, then its closing must be a right parenthesis. Whereas if I am using a left square bracket, then the closing must be done using a right square bracket. That means matching brackets are needed in an expression to term it as valid. Here the opening is a normal left parenthesis, but the closing is not used a right parenthesis. Instead I have used a square parenthesis, and since these two brackets do not match, this expression is also not a valid expression. So an expression can be termed as valid only if there are matching parentheses and there are equal number of left and right parentheses. What about the third expression? When we are talking about the third expression, here the operators and operands are okay. They are right in their position, but left parenthesis is 1 and right parenthesis 0. Here also number of left and right parentheses are not matching. It can be made into a clear-cut valid expression only if I am having a matching right parenthesis. If I am putting a right closing bracket, in this situation the number of parentheses, left parenthesis and right parenthesis are equal. Second, matching parentheses are used in this expression. So clearly the third expression is a valid expression now. So what I am going to teach you in this video is, we will be evaluating certain expressions and we will be checking whether these expressions are valid or not. And for this checking purposes, I am using stack. What I am using? I am using stack data structure to check whether an expression is a valid expression or not. Now let us see how the stack can be used to evaluate whether an expression is valid or not. Moving on to the examples. Now, before moving on to the example, let me make you familiarized with the algorithm that I am going to use here. So clearly we will be reading the expression from the keyboard. So while reading the expression, we have to read one character by one character. Clearly, we have to read separately each character at a time. And in this way, you can read the entire expression. So first step we have to do is read a character. And this character can be having many options. The character can be an operand, it can be an operator, it can be a left parenthesis, and it can be a right parenthesis. So what are the different things you have to do depending on whether the red character is a operator or an operand or a left or a right parenthesis? Let us move on to the algorithm. So first is read a character. What if the character read is a left parenthesis? Left parenthesis can be of two types. It can be a normal left parenthesis or it can be a square opening, left square bracket. Two options are there, either a normal left parenthesis or a left square bracket. So any of these two can be termed as a left parenthesis. Okay, so if the red character is a left parenthesis, what we have to do? We have to simply push it onto the stack. Remember this step. If the character read from the keyboard is a left parenthesis, it can either be a normal left parenthesis or it can be a left square bracket. In either of these two cases, if it is a left parenthesis, simply push it onto the stack. And LP equal to LP plus 1 indicates that left parenthesis should be incremented by 1. So before starting the algorithm, count for left parenthesis. LP is a variable which stores the count for left parenthesis. Before beginning the algorithm, the count should be set to 0. So that when each time you encounter a particular left parenthesis, the count of LP should be incremented by 1. Okay, so what you have to do, if the red character is a left parenthesis, you have to increment the LP, value of LP by 1, and you have to push the character onto the stack. Okay, moving on to next option. If the red character is not a left parenthesis, instead it is an operand or an operator. Okay, so if the red character is an operand or an operator, you have to do nothing. Just move on and go for reading the next character. What is it? If you are reading an operand or an operator, in both these cases, in either of these cases, you have to do nothing and simply move on to the next step by reading the next character. Clear? Now, if the red character is a right parenthesis, so there can be two right parentheses. One, a normal right parenthesis, or a square right bracket. What is it? A square right bracket or a normal right parenthesis. In both these cases, they are generally termed as right parenthesis. So if the red character is a right parenthesis, what we have to do? Yes, we have to increment RP equal to RP by 1, which means RP is a variable which stores the value or the count for number of right parentheses. RP is a variable which stores the value or count of number of right parentheses. Before starting the algorithm, the variable RP should be set to 0. And while we attain or while we access or while we read each character which is a right parenthesis, whenever we encounter a right parenthesis, the value of RP should be incremented by 1. Clear? Okay, now what? Once RP is incremented, we have to do a pop operation. What we have to do? We have to do a pop operation, and whenever we do a pop operation, what happens? The topmost element from the stack is being removed, and the removed element is stored in the variable item. Okay, so I repeat, if you encounter a right parenthesis, then increment RP by 1 and remove the topmost element from the stack, and the removed element should be stored in the variable item. Now what? Now one more thing. If, as I already told you, right brackets can be of two types. It can either be a right square bracket like this, or it can be a normal right bracket like this. So if the character CH, that means which is read from the keyboard, if the character CH is a right normal parenthesis, normal right parenthesis, if the character read is a normal right parenthesis, then we have to check if the item equal to left parenthesis. That means if I have read a right parenthesis using the keyboard, then immediately I will be removing the topmost element from the stack, and the removed element is now stored in the variable item. So this is the item removed from the stack, and this is the item currently read through the keyboard. If a normal right parenthesis is read through the keyboard, then the item which is removed from the stack is matched with it. I repeat, whenever you read a right parenthesis, immediately you have to remove the topmost element from the stack. And you have to compare two things. What are they? You have to compare the CH, that means the character just read, and the value which is removed from the stack. The value removed from the stack will be a left parenthesis, and the value just read is a right parenthesis. So you are now checking whether they are matching or not. So if the read character is a normal right parenthesis, then you have to check if item is a normal left parenthesis. If these two match, then expression is valid up to now. But if the read character is a normal right parenthesis, but the removed character is a square left bracket, that means these two do not match, the right and the left parenthesis do not match, then it is clearly an invalid expression. Similarly, if the read character is a square bracket, square right bracket, if the read character is square, the red square square right bracket, then the character which is removed from the stack should be this thing. I repeat, the character you have just read is a square right bracket, then the character removed from the stack should be a square left bracket, and this removed character is stored in the variable item, and this character is in the variable ch. So if ch is equal to square right bracket, then item should be equal to square left bracket. If this condition satisfies, then up to now the statement is valid or the expression is valid. Otherwise, it is a clear cut case of invalid expression, because if the above condition does not match, then it clearly shows that the opening and the closing brackets do not match, and this shows the expression is invalid. So you now know what you have to do if the red character is a left parenthesis, what you have to do if the red character is an operator or an operand, what you have to do if the red character is a right parenthesis. Now one more thing is there. The last question. The red character can be a dollar. Now why should you read a dollar sign? I will tell you. While reading an expression, this is the only way how you can show that the expression has been ended. You're reading characters or you're entering characters one by one. So after entering the entire expression, if you enter a dollar sign, then the system understands that this is the end of expression and there are no more characters to be read from the keyboard. So dollar sign marks the end of expression. So if ch is equal to dollar, that means character just read is a dollar sign, then system must understand that you have to stop reading. There is no more characters left in the expression to be read. The expression which is read is complete. You have to stop reading characters. Once the character reading stops, immediately you have to check this condition, that whether the number of left parentheses and the number of right parentheses are equal. So in the beginning I told you there are two conditions you have to check. To check whether an expression is valid or not, the first condition you have to check is whether the opening and the closing parentheses match or not. For a normal left opening, you should have a normal right closing. And for a left square bracket, you must have a right square bracket. These are the matching parentheses. In case there arises any such situations where the expression have an unmatched parenthesis, you can immediately exit from the algorithm stating that the expression is invalid. If throughout the expression you are not able to find an unmatched parenthesis, then you have to proceed after reading the last character of the expression. Whenever you encounter a dollar sign, you have to check for the second condition, which is checking whether the number of left parentheses and the number of right parentheses are equal. If this is equal, then it shows that the expression is valid. Otherwise, again you can say that the expression is invalid. Okay, so this is how the algorithm works. So before moving on to the clear-cut cases of different examples, let me summarize the algorithm once again. There are 4 situations. You are reading certain characters from the keyboard. The characters read can be of various types. They can be operators, they can be operands, they can be left parenthesis, or they can be a right parenthesis. If you are reading a left parenthesis, simply insert it or push it onto the stack and increment value of LP by 1. If you are reading an operator or an operand, then you have to do nothing, just go for the next situation and just read the next character. If you are reading a right parenthesis, then check whether it has a matching left parenthesis. And how you can do this checking? You have to remove the topmost element from the stack, and the removed element will be definitely a left parenthesis, and that removed element is matched with the value which is just read now. Element just read now is a right parenthesis and the value just removed is a left parenthesis. You are matching, you are checking whether they are matching or not. If a normal left parenthesis if a normal right parenthesis is read, then the removed character should be a normal left parenthesis. Similarly, if a square right bracket is read, then the removed character should be a square left bracket. In both the situations, if the condition does not match, clearly this is a case of invalid expression. But if these conditions match, then up to now the expression is valid. And if the red character is a dollar sign, it indicates that the expression has been read completely. There are no more characters left. You can stop reading. In that case, you have to check the second condition, which is number of left parentheses and the number of right parentheses. So whenever a right parenthesis encountered, RP increments by 1, and whenever a left parenthesis encountered, LP is incremented by 1. At the end, once the reading is stopped, you can check the counts of these two variables. If LP equals RP, then it is a valid expression. Otherwise, it is an invalid expression. So hope you are clear with the concept of algorithm for expression evaluation. Let us move on to the examples. So this is our first example. The expression is given as bracket left bracket 2 plus 3 right bracket. So first, the character read will be a left parenthesis. The first character read is a left parenthesis. So as per the algorithm, if a left parenthesis is read, it should be pushed onto the stack. So this is our stack. If the red character is a left parenthesis, then push it onto the stack and increment LP by 1. Initially LP was 0, and when the first left bracket is encountered, LP is incremented by 1 and the value of LP is now 1. Now just read the next character. The next character will be 2. So 2 is an operand. If you're reading an operand, do nothing, go for the next character. So I'm reading the next character is plus. It is an operator. As per the algorithm, if you're reading an operator, do nothing and just go for reading the next character. The next character is 3, which is again an operand. Again, if it is an operand, you have to do nothing, just go and read the next character. So the next character is a right square bracket. Whenever you encounter or whenever you read a right square bracket or right parenthesis, what you have to do? Increment rp by 1. So value of rp is rp equal to 1. And since a right parenthesis is encountered, you have to pop the topmost element from the stack, and the topmost element of the stack is this thing. So the character just read is a right square bracket, and the element just removed from the stack top is a left parenthesis. Check whether these two match. No, they are not matching parenthesis, because the right parenthesis is a right square bracket and the left one is a normal left parenthesis. Since these two do not match, we can clearly say that the given expression is an invalid expression. Just print that the expression is invalid and you can exit from the algorithm. So the first example is over. Let us move on to the second example. So here I am having second example. Let us see how this works. So I am having a stack ready with me. I am having two variables LP and RP. Both of them are initialized to 0. So first character read is a left square bracket. If the character just read is a left parenthesis, push it onto the stack. Then value of LP is incremented by 1. Moving on to next character. Next character is again a left bracket. Then it should be added on top of the stack. Left bracket is added or pushed onto the stack, and the value of LP is incremented by 1. So LP is now 2. Now moving on to the next character. Next character is 2, which is an operand. You should do nothing. Moving on to next character. Next character is plus, which is an operator. Again we have to do nothing. Moving on to next character. So I am reading the next character, which is 3. It is an operand. Again we have to do nothing. Since it is an operand, we are moving on to reading the next character. So the next character is a closing bracket. So this time I have encountered a right bracket. Whenever a right bracket is encountered, increment value of RP by 1. And you have to pop the topmost element from the stack, and the topmost element from the stack is this thing. So I am popping the element from the stack, which is a left normal bracket, and the character just read is a right normal bracket. Check whether the character just read now and the character removed now have a matching pair. So this is the case where we have a matching parenthesis, because for a left opening bracket we are having a matching right closing bracket. So brackets are matching. Up to now the expression is valid. Okay, so in our stack we have already popped elements. So now the element which is at the stack top is this thing. Clear? Moving on to next character. Since there are no more characters to be read in this current expression, I am reading the character $sign. I will enter a $sign. Clear? What did I say? I said I am entering a $sign. This $sign indicates that there are no more characters to be read, then the expression is completely entered. So since the expression is completely entered, when the system encounters a $sign, it stops reading and immediately it checks the value of LP and RP. And it finds that number of left parenthesis is equal to 2 and number of right parenthesis is equal to 1. Since they do not match, this example is also an invalid expression. So in the first case, the expression was invalid only because we do not have a matching parenthesis. But in the second case, the expression is invalid because we are not having equal number of left and right parentheses. Clear? Let us move on to the third example. Okay, stack is ready, LP and RP are ready, both of them are initialized to 0. And here I am reading the first character as left open bracket. So since it is a left bracket, it is entered onto the stack and value of LP is incremented by 1. Next character is read, which is 2. It is an operand. We have to do nothing. Moving on to next reading. I read plus, which is an operator. Again we have to do nothing. Moving on to the next character. I have read 3. It is an operand. Again I have to do nothing. Since it is an operand, I am moving to read the next character. This time I have read the right closing bracket. Whenever a right parenthesis is read, you have to increment RP by 1 and pop the topmost element from the stack, and the stack top contains this thing. So the element which is popped is stored in the variable item. The character just read is ch, which is stored in ch. Check whether the character just read matches with the character removed from the stack. So I am checking whether these two are matching parentheses or not. They are matching. The parentheses are matching. So which means up to now the expression is valid. There are no more elements to be read, so I am now reading the last character as $. System finds a dollar sign. It indicates that no more characters are there. Expression is completely read. So I am stopping the reading activity, and now I am going to check whether LP and RP are equal. LP equal to 1, RP equal to 1, which means up to now I am having matching parenthesis. That means for every closing parenthesis I am having a matching left parenthesis. And up to now the LP and RP are equal. Number of left parenthesis and the number of right parenthesis are equal. That means both the conditions are true up to now. What are the two conditions? An expression is said to be valid only if the number of left parenthesis and the right parenthesis match. And for every right bracket you should have a matching left bracket. And in the given example, both these conditions are satisfied up to now. So this is a case of clear-cut a valid expression. So in this way, I can use stack data structure to check whether an expression is valid or not. Hope you all are clear with the concepts. Thank you.